Okay, everyone. So let's start. Come on, lots of things to do today. We have a handout to go through. This one, a slideshow, and we also have a practice worksheet. Okay, your first practice worksheet for the unit. Remember, practice worksheets are not for what? Are not for marks. They're just basically things that we mostly get to do here. If we ever run out of time for a practice worksheet, that becomes your homework, basically. Okay. Okay. What was the thing we covered yesterday? Come on, let's regroup. What was the only single topic we covered yesterday? Huh? Yeah. So kinematics, and what was the first kinematic quantity? But so vector was the nature of it. What was the name of it? Position. Okay, and we said that from position you create what? You create everything in kinematics. So today we start with the what? With the first result of position, which is called what? Displacement. Okay, so displacement. So displacement is basically what results when an object moves from some starting position to some ending position. Okay? Whenever that happens, the object is said to have experienced position displacement. No one says position displacement. Everyone just says what? Displacement. Okay? Everyone says displacement. Okay? Um, so physically speaking, the definition of displacement is the following. Go ahead. I think you have to copy that one down. The definition of displacement is the change in position, the change in position from, now you have to get used to this word. I mean, it's not really super new, but it might be new to some of you. We don't usually say starting anymore. We say initial. Get used to the word initial in science and math. Okay. Initial, like initiate, means the beginning of something. Okay. So from an initial position to this is much easier than the initial. This is basically ending or final position. Okay. So displacement is the change in position from an initial location to a final location. Okay. In other words, displacement is the difference from the initial position of an object to the final position of the object. So still everything still is building on position from yesterday. Okay, let's go to the next slide. All right. What was the physical symbol for position from yesterday? Not so don't you again is the physical symbol and unit the same thing? No, units is what you tell me, oh, 5 centimeters, 3 kilograms, and so on. Physical symbol is what appears in the math. What was the physical symbol for position? Perfect. Lowercase d with a what? With with a vector sign or with an arrow on top because it's a vector. So what is the physical symbol for what? For displacement. Well, it's interesting because it's very much related to what? To position. So the symbol for displacement is this. Who knows the name for that triangle? Delta. How many people know that was delta? Delta is one of the most important. Delta actually is a Greek character. Alpha, beta, gamma, delta. It's basically A, B, C, D in Greek. D is delta in Greek. Okay. Delta is one of the most important symbols in all of math and science. You will never stop seeing it. I don't care what science or engineering you ever do. Delta will always be there. Okay. Why? Because it has a very important meaning. Okay. Thank you. So the triangle symbol is the mathematical way of indicating a difference or change. Every time you see delta in any equation, it means something has changed. Something has gone through a difference or a change. Okay? By the way, that doesn't always mean that the difference is more or less than zero. The difference could still be what? Zero. But that still means that something changed, but apparently it came back to what? To the original value. Okay? We're gonna get through so many questions like that. So you don't worry if it's not understood perfectly. You will see what I mean. In other words, it indicates some quantity went from some initial value to somewhat final value. They still could be the same values. Maybe you came back to, it's like, let's say, for example, your weight change, okay? Maybe you're at some weight and then you gained or lost some weight and then somehow you came back to the same weight. Well, technically, this is your initial, this is your final, even though they are the what? The same. But some process has changed in the middle, okay? Examples are, what do you think lowercase t stands for in almost any math or science course? Say again? Time. Yes, absolutely. So what does this mean? Delta t would mean change in what? Change in time. Perfect. So this would be change in time. How about capital V? Actually, okay, you will see. Oh, we got to cover velocity in a couple of tomorrow. We got to cover velocity. Actually, point, velocity is actually small v. So what could be capital V? Okay. Also, speed is, so voltage, where we got to cover it in electricity and magnetism. Also, what? From math, it's volume. Perfect. Ali, what do you want to say? Volume? Yes. So volume in math, voltage in electricity and magnetism. What's voltage, by the way? Voltage is basically the powering source of absolutely any electrical socket. We're going to cover that so much. Batteries and so on. Okay. Yeah, I chose volume. Who cares? You can call it volume or voltage. Okay. How about this one? Exact. Change in whatever that symbol is. So change in something, whatever is represented by the question mark. Okay. Now here's my question. Since displacement is based on what? Is based on what? Position. And position was a vector. Displacement is also a what? A vector. Perfect. So since displacement is defined using position, from which is vector, that means it also retains the vector nature. Good. By the way, just so you know, the arrow does not extend to cover the what? The triangle. It's this one that's the vector. This is the change in the vector. So the whole thing is not a vector. This is just the vector. This is just the change in it. Okay? So important to know the meaning of the symbol. Okay? All right. So let's go to the next slide. Okay. What was the physical unit for what do you call it? For position? By the way, from now on, perfect. From now on, whenever I ask what's the physical unit, instead of giving me 10 different units, always give me just the what? The standard system unit. What is it? It's meters. So since position is related to since displacement is related to position, it's also in meters as well. Nice. Okay. All right. So lowercase m for meters. Okay. What is the equation or the mathematical formula for position? All right. Today we're going to do, sorry, I mean for displacement, my bad. Okay. Ladies and gentlemen, the mathematical formula or definition of displacement is, there we go. Go ahead. Displacement is nothing but final position subtract initial position. Okay, by the way, I always like to give the word equation and then give the mathematical equation. Always seeing the words make it really have what? Have a meaning to it. So how would I write this in a mathematical notation? Well, we just covered the symbol for displacement. What was it? Delta D. What's the symbol for position? Just a what? Just a D. But I need to indicate it's a final. What do you think we should use here? Whenever you want to indicate final, initial, or first and last, what are common things that math and science people do? No, no, like a like within the symbol itself. Okay, I'll give you a hint. Who remembers the slope equation? Come on, from grade 9 or 10. What is it? That's the straight line equation. Remember, okay, hold on. What he said, y equals mx plus b, is the straight line equation, right? I'm asking just the slope. M equals what over what? Y2 minus y1 over x2 minus x1, right? The slope is the what? The rise over run, or change in y's divided by change in what? In what? In x's. So what did you put under the y's and the x's? You put what numbers? Subscript. Thank you, subscript. We don't, okay, in this course, we're not going to use 1 and 2. We just used initial and final. So what should we use? I and exactly. There we go. Boom. That's it. This is the equation for displacement in mathematical form. Delta D equals final position minus initial position. By the way, I have a question for you. Could you ever do initial minus final? Why is it always final minus initial? Like, by the way, just so you know, how many people sometimes, and I'm pretty sure some of you went through that because I went through that. How many times, listen up, did you have the teacher ask you calculate the slope and you wrote the equation y1 minus y2 over x1 minus x2? Come on, admit to it. I did. Here's the weird thing. You still got the right answer. Do you know that if you did y1 minus y2 over x1 minus x2, you're still going to get the same exact answer as y2 minus y1 over x2, yet you lost marks. And the teacher said, this is incorrect. Unless it was a multiple choice, they wouldn't know. But they would say, this is incorrect. You wrote it incorrectly. I can't give you full marks, even though you got the right answer. Because double negative is a what? You did not just flip one part of the fraction, you flipped what? You flipped both. So basically, you still what? Got the exact same answer. But my question, but I always had students come up to me and say, Mr. Ramadan, Mr. Shivers, or Mr. Fonseca, still took marks off, even though I got the right answer. Why can it be y1 minus y2 over x1 minus x2, even though it gives you the right answer? For Say again? No, it doesn't have to be. Depending on the slope, right? Sometimes it goes up, sometimes it goes down. Like there's no reason to believe that's not working for decreasing or increasing line, right? Has nothing to do with the magnitude of the number. It has to do with logic. Question for you, everyone. If you study from 2 p.m. until 3 p.m., how many hours did you study for? No, from 2 p.m. to 2 p.m. to 5 p.m. My bad. How did you do that? Why can't you do 2 minus 5? Because which time comes exactly? Which time comes first, initial or final? No, comes first. Initial. Can you ever do initial minus final? No, because 2 p.m. minus 5 p.m. means what? You studied for how many hours? Does that make sense? Exactly. That's why you can never do what? Initial minus final. You always do what? Because final always comes what? After initial. And that's the reason why they never accept y1 minus y2 over x1 minus x2. Because, by the way, how does the x-axis go? To the left or to the right? Come on. How does the x-axis increase? To the right, which means what? This point always comes after this point. That's why it's x2 minus x2 minus x1. Do you see what I mean? It's the logic of time. Further time comes after before time. That's why. Okay, I just want to mention that. Okay, ladies and gentlemen, pencils down. Let's just look at this example. I want to give you a one-dimensional example first, kind of like what we did yesterday. Also, not to scale. So everyone, consider the following not to scale sequence of trips. What does sequence mean? Yeah, go ahead. Exactly, but in what? In a specific order. Thank you. So apparently, we have the following sequence of events. All right. We have a person who apparently started here, and apparently we're going to call that what? If they started there. Thank you. If they start somewhere, it is logical to call that the origin. Their first trip took them to this point. To this point. Okay? All right. Their second trip took them here. Oh, I have numbers afterwards. Okay. My bad. So this is the origin. Their first trip took them to what? 1360 meters. In which direction? Right or east. Good. Their second trip, that's trip number one. Their second trip, sorry, took them here in the position marked as 920 meters compared to what in the origin? West. Thank you. And their last trip took them to 340 meters. Which way of the origin? Nice. Okay. So the question now, yes, the numbers indicate position values or position markers on a what? On a meter stick, let's say. Yes, on a number line. How many people have heard of number line? This is legit a number line. Okay. Question number one. What is the displacement of trip numero uno? Number one. Okay, question for you. What's the equation for displacement? I just showed it to you. Delta D equals final position minus. Good. So here it is. Can someone tell me, only looking at trip one, come on, only look at trip one, what's the final position of trip one? What? Come on. Position is a vector. You have to give me three things: a number, a unit, and a direction. Exactly. The position here of trip one, where's trip one? Trip one is here. Trip one was final at what? 1360 meters. Which way of the origin? Where did it start? At the origin. What's the value always for the origin? Zero. It's the center of the universe. Perfect. Okay. By the way, this is always a matter of debate. Why did we put east with zero? People always, by the way, people always say, but zero doesn't have a direction, right? Because zero is very what? It's very what? It's not just very small. It is absolutely nothing, right? Well, here's the thing. Why would you put this as west when you have this one as what? Yes, always try to make your directions the what? Thank you. Okay. So if the directions are the same, can I just proceed with the math now? Yes. What is 1360 minus 0? No surprise there. Does that make sense as far as their motion is concerned? Yeah, I mean, if you trace their motion, they moved this way, which is east, and they did move a distance in space of 1360 meters. Yes, that's it. That's all we had to do for what? For trip number one. What's the next question? Obviously, trip number two. Okay, everyone. So let's go to trip number two. I'll give you a few seconds to finish copying this one. By the way, when the others are copying, if you wanna start trip number two, go ahead. Just even without writing, just kind of deciding what numbers you need to put down. Oh, is it 3 lines? Oh, sorry, everyone. I have 3 lines for you. Apparently, we only need 2 lines. My bad. Sorry. Yes. Oh, so okay. Everyone, listen up. Hannah has a very good question. Is there any reason the directions are the same? The only reason that the directions are the same is because one of the positions is exactly how much? I can. By the way, everyone, zero could have any direction you want. You can make it north even. You can make it south. But to make the math easy, what do you make it? The same as east. You got it. That's it. All right, everyone. Next one. Trip number two. Can someone tell me what's the final position of trip number two? Raise your hand. Always raise your hand. Trip. Oh, hold on. Okay, Baha. What is the final position at which the person ended at the end of number two? 920 meters west. What is the initial position of trip number two? Because it follows after what? Trip number one. The ending of one is the beginning of the other. So that means the beginning is this. How many people agree with that? Oh, the beginning. Oh, sorry. The beginning of the ending of one trip is the beginning of the trip after it. You said it. It's a sequence. Yeah. So that means what? It's 920 west minus 1360 east. What's the problem here? Okay, hold on. I love this discussion. Question for you, everyone. Can we proceed now with the math? No, there's a huge problem. The directions are what? Not just only the same, they're what? They're perfectly opposite to each other, which means what? You can never deal with vectors in one dimension unless they point exactly in the what? In the same direction. So you have a choice. You can either flip this west and become what? Or flip this east and become? Okay, but there's a price to pay. What is the price you have to pay whenever you flip the direction of a vector? Does anyone know? You have to change the what? If the vector was given a positive magnitude, like this guy, and this one becomes east, this one has to become what? That's permissible. However, there's always a smarter way to do things. If you flip this one, it becomes what? So you win. Also, this one becomes what? And your final answer now is already naturally what? positive to, do you see what I mean? If you did the opposite, if you flip this one, this becomes what? What do you get when you add a negative? When you add a negative to a negative? No, add, not multiply or divide. Add. Remember, when you lose and then you lose more, you still what? You not doubled. You deepened your loss, right? You increased your loss, which means everyone, listen up. If you flip the first one, you're gonna get a negative with a negative as an addition. What do you get? You get no. When you add, you get a deeper negative. But is it good to have? That's my point. Is it really again? Okay. Is it really good to have a physical sense for distance or displacement as negative? No. We want things to come what? As by the way, sometimes things are what? Negative, like temperature outside, for example. You cannot control that. But sometimes you can what? Make them what? Positive. So what should you always flip? The first one or the second one? The second, because it already comes with a what? Nice. But you have to pay the price of what? Of flipping the direction as well. Great. Okay. So this is the problematic one. And now, do I just commence with the math? Absolutely. What is 920 plus 1360? How much? 2,280 meters. Which direction, though? Exactly. Does that make sense as far as the diagram is concerned? Yeah, look how they moved. They moved from here to this direction, which is going which way? Going west. Now, how come this is correct? Well, think about it. First, they had to go from where? No, from where? To what? And then, exactly. Then go from the origin to the what? Do you see how I said then go? That means they what? That's the addition. The addition is because you have to go and then you have to overshoot it to get to that. That's why they have to add. Okay? Nice. No. The direction actually happens to be correct because look how they moved. They moved in trip number 2. They moved which direction? East or west? By the way, everyone listen up. Question for you. Everyone, this is actually very important. Here's the where's the okay. I have I'll just get the marker here. Okay, everyone, I have a thought experiment or a logical question for you. Everyone, eyes up there. Question for you. Eyes up here. Oops, sorry. Okay. Number line, direction line, whatever you call it. This is the what? Origin. Okay. This is the which direction? No. And this is what? Okay. If I moved from here to here, regardless of the number, which way did I move? Physically, which way was I pushed? I was pushed west. Someone might say, yeah, of course it makes sense. You moved from where to where? On the eastbound to the what? Here's a question for you. Maybe some of you are seeing where I'm going. Which way is my displacement here? Which way was I pushed? Was I pushed east or west? I was pushed west. But yet, I ended up on which side? Do you see my point here? The displacement, you know what? You actually inspired me to come up with this example because I've never actually what? Heard the question that you said. You said that they what? That you said that the direction is wrong, right? Just because you end on the west side does not mean you had to travel which way. Your position has nothing to do with which way you were pushed, right? Here, you purely stayed on which side of the universe, yet you were pushed which way? How about here? Interesting. You were both pushed west and you also stayed on which side of the universe? And so on. Do you see what I mean? You could get every which possible combination. Nice. Good. So again, if you want to check, look at the diagram, look at the number, just make it make sense. Yes, make sense? So in a way, they did move from east to west, but that still just means what? They were pushed in the west way. Okay? All right. What is the last question, obviously? Trip number 1, trip number 2, trip number 3. Okay, you know what? Go ahead. You have a couple of minutes for this one. Go. It's exactly the same kind of work, but let's see what we get. Strip number 3. More exactly. How do you, okay, remember, there are two directions now being dealt with. The direction of the position markers and the direction of the shoving displacement. Again, they might be the same, they might be different. That example tells you exactly that they could be anything. Yes. By the way, no need for question. Just do it. Have it there. Do not change it if you think it's wrong. We'll take it up anyway. What's up? Sure. Yeah. I just want to know which one would be the more correct one. Third C is triple three. Okay. You know what? I'll do it the correct way, and then you'll tell me the other way, and I'll tell you why it's wrong. Okay. Good. I love. Okay. I always say it's more important to discover your weaknesses than your strengths. Yes. I believe so. Come on. 30 seconds. Yep. How many people are done? No rush. We have so much time. Okay. Sorry, but I want to keep explaining, but just one thing, everyone listen up. There's a reason I sometimes jump around and I give you these quick logical challenges. These actually are common in not just my own true, false, and multiple choice quizzes and tests. University, if you know anyone who's doing like in first year physics, usually the first half of the test is like true, false, multiple choice as well, or quizzes and stuff, and they love these ones because they can just say what? That's it. It's either right or wrong. Do you see what I mean? And it's important because you're like, oh, now I understand why it makes sense. So these are important to understand. Physics is not just numbers. It's also, can you explain the process? Okay, let's do this. So can someone tell me what is the final position of trip number 3? He ended or she ended or they ended at, what was it? 340 meters east of the origin. Is that a displacement or a position value? Good. Always make sure you understand displacement and position are related, but they're not the what? They're not the same. They're not identical. They're related though. So the final position is 340 meters east. What was the initial position of trip number 3? It was the final position of trip number what? Of trip number 2, because it followed exactly after it. Where is the problem here? The negativity in the what? In the west. Or as one of my. Oh, hold on! Don't change it. Don't change it. Leave it. These are your battle wounds. These are your battle scars. Keep them. Trust me. I swear I became a very good teacher because I failed so much. I love it. By the way, so what's the problem? The problem is the what? As of one of my former students, the problem is the west. Okay. So what happens here? West changes to what? And what do we get? We got a positive sign. So what happens here now? What's 340 plus 920? How much exactly? Which direction? Of course. Does that make sense? Yes, because if they moved from here to here, I don't care they start from west. I don't care they ended east. I care they moved which way? Towards they got more east, more eastern. That's why. So the final answer is what? Is done. But what was the other method that produced a different answer? What did you exactly do? Listen up, everyone. 200. There was a 280. Oh, you used the 1280. Okay, hold on. Question, everyone. The 1280. Listen up. Everyone, listen up. By the way, this is an example of a problem where technically part C does not depend on part B. I mean, usually math and physics problem, part A gives you part B, part 1280, is it a position value or a displacement value? Yet here you're only asked to use what? Position. You see how? You use something where it's actually not meant to be used for it. That's why. Nice. Yes. No, the displacement vector is neither this value for trip number 2 is neither this value nor this value. It's the difference between them. Yeah.
Like you're going eastward.
Okay. Yeah.
You end up on the west side of the origin, you would still write it.
Yes. It's
And then for position, you just write it as well.
just because you ended where you ended. Exactly. Everyone, listen. Everyone, eyes up here. Position is where you what? Where you end up. Displacement is how you what? You got it. How you move. Perfect. Okay. Question for you, everyone. I asked you for trip number what? Number what? Number what? Is there any more I can ask you for? Yes, you already have it, the overall. Okay. What's one way to do overall? Add up all the overall trips. Well, let's do that. Okay, hold on. How many trips did I take? I took 3. Okay, overall would be what? Number 1 plus number 2 plus number 3. Do we have all the numbers we need? Sorry, all the yeah. We know the displacement for trip number 1. We know it for trip number 2. We know for trip number 3. So, what should I do here? There's 1 west and 2 east. Okay, here's a question for you. What if I have, obviously I'm never going to give you that, but what if you have 20 vectors to add and 7 of them are east and 13 of them are west? Technically, do you really have to see which one wins and then flip, or can you just randomly flip and see what happens? Exactly. Think about it. What's the worst that could happen? You flip all the east to west and you end up with a what answer? With a negative answer. Is that so bad? No. At the end, what do you do with that answer? You flip it back. What's the good thing that could happen? Whatever you flipped worked out in your advantage. Do you see what I mean? So whenever you have a lot of vectors, don't waste time seeing, I wonder which direction is going to win. Who cares? Just flip something. And then you're only one step away from what? From flipping it if you needed to. Here, which one do you think is going to win? The combination of the easts or the one single west? Just by looking at the numbers. It seems that 1260 plus what? 1360 is not as big, sorry, is bigger than what? Okay, so I guess the east is going to win. So which one should we flip? A single west? Let's do that. Ta-da. And now I can do what? A legit subtraction / addition with only numbers. I don't care about signs, sorry, about directions anymore because they've been what? They've been standardized. What's the final answer? What? Is that? Okay, hold on. Is 340 a part of the original problem? Like, was it a part of the original inputs? So was that just how numbers played out? A coincidence? Or is there a reason behind that? There has to be there's no coincidence in math. There's always a reason. Question for you, everyone. Can someone remind me again what's the definition of displacement in general? Come on. What's the equation for displacement? Go. Okay, what's the equation? Final minus. Okay, hold on, everyone. Pencils down. Let this sink in. What does this question say? What's the displacement of the what? Of the overall trip. Hold on. Do I know the position, sorry, the initial position of the whole trip? What was the initial position of the entire experiment? Where did the entire experiment begin from? No. Where was that person at the very beginning? The origin, which is given what? 0. Where was that person at the very end of the whole experiment? What do you conclude now about displacement? Does it care about intermediate step? No. Ladies and gentlemen, displacement, I always like to think of it this way. Displacement is what I like to call the passive observer. What does passive mean? What's the difference between passive and active? What's the difference between passive and active? Passive observer, active observer is someone who's what? Watching the whole time. They're never missing a beat. What about a passive observer? Are they looking? No. You just look. You just tell them, move. I turn. I have no idea what's going on. And then you tell me I'm done. I look back. Where do I see you? All I saw was that you moved from where to. I have no idea what you did in the middle. So what do I just do? Final minus. Do you see what I mean? Why consider all the intermediate trips when you can just consider the very first and the very what? And the very last. Amen. Okay? So that's the best thing about displacement. Overall displacement. It doesn't care about intermediate steps, which makes it what? Harder or easier? Easier, because if you know the very first and the very last, who cares about what happened in the middle? You could have had 100 trips in the middle. Yes. Okay, thank you. The length or the distance you traveled does what now? Does count. Do you see what I mean here? Okay, everyone. Question, everyone. Listen up. Question for you. Eyes on me. What direction did we say this was yesterday? That. So this has to be what? Okay. In steps, what's my displacement? In steps. 3 steps. Which way? South. In steps, what's my displacement now? Displacement. Displacement is what? Final minus initial. If my final and initial are the same, what happens when you subtract a number minus itself? What do you get? So was I displaced? But did I actually move that distance? Do you see the difference here? What was my total distance, by the way? 6. Yet my displacement is what? Do you see the difference now? This is why I have to teach you this way. The language matters. And that's why. Okay, so you're right. So you're right. The active observer sees the what? Sees the distance. The passive observer only sees the what? The displacement. Because they have no idea what happened in the middle. That's the difference. Uh-huh. Is what? Sorry? Oh, so that's what we'll cover tomorrow. You're cluing into it. You're absolutely right. Yes. Okay? There we go. How many people agree with this now? Yeah. The very final or the very last minus the very beginning. They ended at the end at 340 east. And where did they begin? By the way, I have a question for you. Hannah, to your point. What if I made this 0 meters west? Technically, am I correct? Technically. I am correct. 0 accepts any what? Any what? Any, because technically it has, by the way, it's a debate among mathematicians to this day. Does 0 have a direction? Sorry, does it have no direction or does it have all the directions? Do you see what I mean? Some people say it has no direction because it has no size. And some people say you can put any directions to it because then you're multiplying it by 0, making it what? 0 is the only number that kills anything multiplied by it. Because of that reason, you can put any direction to it. But if you made it west, if you made this west, then you have to make it what initially? East, which means, does it matter if you're adding a 0 or negative or negating it? Exactly. That's why I say what? Just put it exactly the same as what? As the other direction. You see what I mean? No difference whatsoever. Make sense? So it's a philosophical idea, but because it's a 0, put it exactly as everything else. Yes. Okay. Okay. I am reading. I already read your mind. Everyone, what if someone says this? Everyone, eyes on the screen. What if someone just put 0 meters? Are they correct? What do you think? Can you ever add or subtract a vector to a non-vector? No way. Directions always have to combine what? Together, which means a number and a vector cannot be combined. You only can combine what together? Either 2 numbers or 2 what? Which is why we have to what? We have to slap a what? A direction next to the what? Next to this. Do you see what I mean? By the way, who's gonna take calculus and vectors? These are the tricks that Mr. Shivers will actually give you in his test. This is a correct statement. 5 meters east plus 0 meters equals 5 meters east. Even though we understand what he's trying to say, or we understand what the question means, it is what mathematically or as a syntax is incorrect. Because you cannot combine a what with a what? A non-vector or a number with a vector. Perfect. Nice. So here, there we go. Conclusion, displacement could not care less about intermediate step. Just know when it began, sorry, where it began, not when, where it began, where it ended. Period. Done. Is the idea of displacement sinking in now? Okay, good. Again, vectors 1D are becoming, you know what, a natural thing to you, ladies and gentlemen. Good. Yes, go ahead. Yes, shoot a question anytime. This is the concept. You can even do vectors in 4 dimensions if you study Einstein's theory of relativity. However, the good news is, everyone, in grade 11 and 12, we only go up to what? 2D. In 3D, I show you an example. I do not test you on it, even in grade 12. But in calculus and vectors with Mr. Shivers, you actually do what? You actually do what? 3-dimensional X, Y, and yes, you have to. And obviously, in first year engineering or science, you have got to be what? Somewhat proficient in 3-dimensional geometry. Okay? All right. Was the question we did so far 2-dimensional or 1-dimensional? By the way, is this 1D or 2D? Do you have any idea how many people think this is 2-dimensional? Why do you think some people think this is 2-dimensional? No, forget the dots. Forget the dots. Forget the dots. What if I just have a straight line? Why do you think some people think it's 2-dimensional? In a way, you can move what? East or. So to them, they think what? Direction of motion is the same as the what? The dimension of the space. Do you see what I mean? No. One line is only how many dimensions? So what's 2 dimensions? How many lines? Exactly. An X and a plane. A plane is how many? A paper is what? Is a paper 1-dimensional or 2-dimensional? A paper is 2-dimensional because a plane could fit inside of it, right? Like an XY. How about a pencil? Is it 1D or 2D? Well, if you abstract it, if you make it like an ideal straight line, it becomes what? 1-dimensional. How about a chair? Yeah. Why? Because it exists in how much space? 3-dimensional space. Is it making sense? So it's not that. By the way, if they think that this is 2-dimensional, then a 2D space would be how many dimensions? Technically 4, because I could move west, east, what? No. Every line only counts as how many dimensions? 1. So this is 1 dimension, 2 dimensions, 3 dimensions. Is it making sense? This is, yes, 3D. X line, Y line, Z line. Make sense? Good. All right. So let's jump to what? Let's jump to what? To 2 dimension. The second case of what? Of displacement. Okay. All right. Practice sheet number 1. There we go. Very basic, but it will review things just in case they need to be reviewed. Okay. Very basic problem. Let's see who would like to read it. Yasmin, go ahead. Do the honors. Read the problem for us. So I already told you the what. What is this point? It has to be the starting point. Okay. So Yasmin, which one was the first one? Oh, go ahead. Rulers, anyone? Because one question is asking to trace. I'll just give 2. Okay, go ahead. 4 kilometers. Which way? I guess west has to be which way? Left or right? Yeah, I don't have enough space to move right, so it has to be left. Go ahead. South. Mm-hmm. Yeah, absolutely. Keep going. Go ahead. Everyone, go quickly. Trace that. By the way, I will not take marks off. This is why this is highlighted or circled there from last course, from last 3U or 4U. I will not take marks off if you don't indicate what the direction of every segment of the trip, like every part, every piece. However, just make sure that you at least indicate the direction of the very last segment, okay? Because that will tell you the start and the end. So as Yasmin said, trace it, label your beginning as a start and your final as an end. All right, that's it. Anything else? On the grid, draw the path. That's it. Everyone, all you have to do for part A is legit just draw the path. Don't do anything anymore. Okay? All right. So far, so good? Okay. Sally, would you mind reading part B? Everyone, listen up. Sorry, go ahead. Say again. How long is this guy? By the way, question to everyone. Why do you think I made it dashed? Everything else was solid. Why do you think I opted for this one to be dashed? Say again? Virtual. So what does that mean? Did it really happen? Is it more of a mathematical thing to help me out? Yes. By the way, in general, this is what teachers and professors like. Anything that really happened, make it solid. Anything that you're just adding to the system to make your life easier or to make the math possible, you make it dash. Although technically, if you made it solid, I will not take a mark off. I'll circle it and comment, but I sure cannot say this is wrong. How am I gonna find the direction? Sorry, not the direction. That's part C. How am I gonna find the length of that dotted line right there? Don't say it. Raise your hand if you think you know. By the way, without measuring, because oftentimes I wouldn't give you a grid. Okay, oftentimes I'm gonna give you just a blank space and you sketch something quick, like not to scale. So measurement rulers, any geometry kits, out of the question. We have to use this guy. Not tools, we have to use our brain. So Yasmin has an idea. Who else might have like even a guess of how to approach this? How am I gonna find perfectly with math the length of this guy? Yasmin, go for it. We're gonna add. I need to bring a laser pointer tomorrow. Which distances are you talking about? There's a bunch of distances here. Like, what are we talking about? By the way, she's not wrong. Go ahead. From 4. Hmm. Hold on. If you did that, you are not gonna get the length of this line. You're merely just gonna get, let's say, for example, someone is exercising and I speed walk all the time. I walked this much. This is just how much the whole thing is. I'm not interested in physically what following the car. I'm interested in, everyone look, the car starts moving. I don't look until the car just gets where? To the end. I have no idea how the car moves. I'm just going to assume what? Beginning to end, straight line, B line. Who has an idea of how to calculate this one without using rulers or anything? All right. Omar, what do you think? Sure, you're not wrong. Keep going, though. You're on the right track. Oh, hold on. Okay, you know what? You did give us the first step. Perfect. Yasmin, do you want to redeem yourself? Divide what? But that's actually sadly impossible because I could know exactly where it perfectly cuts here and where it perfectly cuts here. Ali. I did. Uh-huh. Uh-huh. Yeah, uh-huh. Perfect. Done. There's a right triangle there that you have to show it to yourself. Is it making sense now? Do you see why I love teaching physics? That's why. The discovery. By the way, how many right triangles can you make with this long hypotenuse? One or two? You can make two. You can make the lower one or the what? Upper one. I have a habit of usually using the lower one. The one with the base, not a ceiling. Done. Go ahead, everyone. Create that on your grid. Again, why is it dashed? because it didn't really happen. We are just adding math to it now. Okay? And now we see the what? We see our good friend, the right triangle. What is the only theorem perfectly obeyed 24/7, 365 days a year with by any right angle triangle? The Pythagorean theorem. Yes, thank you. All right. So I'm going to go now to the next slide where, okay, so how would I like you to do this? Everyone? Sorry. So if you can just, whenever there's a big diagram with lots of details, and I really just you want to use the basics of it, I extract it and I just put it, right here. So everyone in here, just sketch what? A rough right triangle with what length now? Ali, you said what? How much did we move down? 11, and this one is 11. Oh, sorry, 10. So go ahead and basically just sketch. Sorry, forget all that. Just sketch this one. Oh, and by the way, at this stage, I don't care if you sketch it solid or dashed. Really doesn't matter. It's what you put on the diagram that counts. Okay? Again, do not put any of those red numbers. Just put start, end, and that's it. Okay, what's the Pythagorean theorem? Either in words or in symbols. Hannah, if you want. Oh, squared. So, or to the power of a squared plus b squared. Or you can say what? Yes. So everyone, I just finished teaching this in period 1. So why do they give you two versions of it? Depending on what you want to find. If you're given a and b and you want to find what? C, then you start by saying what? C squared equal a squared plus b squared. Why? Because your C is already on the left side and it's clean and everything is arranged where you want it. What if you were given C and A and you want to find B, or C and B and you want to find A? Then you say a squared plus b squared equals c squared, and you just what? Shift it or move it to the other side. Perfect. Okay, so obviously the equation is hypotenuse squared equals side 1 plus side 2, or in mathematical lingo, c squared equal a squared plus b squared. Does it matter which one is a and which one is b? Absolutely not. I do remember a student once who said, I asked him, he was very adamant, that was like 5 or 6 years ago, that a has to be the short side. Hold on. See, that's why I love teaching. I get to see what gaps you bring and seal them. So he was like, A has to be the short side. I'm like, why? He's like, this is how it is. I love when people say this is how it is. It's never how it is. There's always a reason, but they don't understand it. Okay? I was like, okay, I have a theory that shoots your logic down right away. What if both sides are the same? You know what he said to my face? I, I gotta say that I loved his confidence. Or I would pay money to get his confidence. He said, then the Pythagorean theorem does not work. You see what bad education he brings from public school? They all start A is the short one, B is the long one, and C is the hypotenuse. I'm like, what if both are the same? Then it doesn't work. No, no. You know what that means? That means to that student, this triangle right here, this triangle, this guy is legit because it has a long side and a what? This one is fake. That's what they think. I'm like, but I have it. It's in my hand. It's created. It's right angle. It's like, yeah, but the Pythagorean theorem does not work on it. I proved it to him that it doesn't work. We measured, we applied the Pythagorean. He's like, how? I'm like, what did you learn in public school? Sadly, people are just fixated on things and they never think it twice. Anyway, all right. So that's, I forget that those symbols. I used to ask people to memorize equations. Who cares? You've got online things now. So 10 squared plus 11 squared, which is 100. Forget this dot. We're going to talk about these things. By the way, everyone, don't put this dot now. We're going to talk about sig figs before this week is done. So, because it needs to be discussed. 1, 221. Is that your final answer? Is that how long the hypotenuse is? No. What's missing from the process? Square rooting. You cannot leave a variable with any power on top. You have got to depower it. So, what's the square root of 221? 14.9. Now, why is why am I saying 14.9 is not? It needs to be rounded to 15. What are the number of all the significant figures in your inputs? Exactly. I have 4.0, 6.7.0, whatever. So all of them come with what? Everyone, all of them come with what? All your numbers in the input are given to what? To 2 digits. So 14.9 is 3 digits. You need to make the cut right here. The 9 makes up for a what? 5, so it makes it 15. Good. That's it. That's it for part B. That's it for part B. Okay? Muhammad, what is part C? Everyone, listen up. What is part C? So go ahead again. The what? Exactly. It is not enough to give me the magnitude or the length. I need you to tell me, look, everyone, eyes on me. I need you to tell me the what? The what? The exact. How much of a direction I need. Okay. Everyone, let's look at this triangle. This triangle is what kind of a triangle? So one thing that applies to every right triangle is the Pythagorean theorem. What's the other thing that applies also to only right triangle? So, katoa, can you tell us what that means? So stands for what? Sine, opposite, and hypotenuse. Ka stands for what? Cosine, adjacent, and hypotenuse. And toa stands for what? Tangent, opposite, and adjacent. My question to you is, everyone, technically now, do I know this guy? So if you really think about it, I can use sine, I can use cosine, and I can use what? I can use any of the trig ratios because I know how many sides of the triangle. Should I really? Like, okay, by the way, what's the whole point here? We need to find the angle where? By the way, never find the angle at the what? You don't tell people how they're supposed to end. You tell them how they what? How they start and then they go. Always find the angle at the start corner or the start vertex. Okay, so my question to you is now, if I put, by the way, does anyone know what's the symbol? What's the name for this symbol? The most famous symbol for angles in math. No one calls angles X. They call it what? Theta. Theta. Oh, no. You're more like Egyptian Arab. Yes. Okay. So obviously it's what? It's alpha, beta, gamma. By the way, theta is the what? Is the Greek Q. If you correspond the letters, A is alpha, B is beta, C is gamma, and so on. Q is theta. Okay. By the way, I have yet to see a teacher who uses X if they want to find out what. Yeah, almost everyone uses theta is reserved for angles. My question to you is, everyone, pencils down. Let's look here. If you have here, this one is by default what? Hypotenuse. If you're here, this one becomes your what? It's right in your face, which means this one has got to be the last one, which is great. Okay. My question to you is, if I want to use sine, sine is equal to what over what? Come on, sine is equal to what over what? So opposite over. Okay, what's my opposite? What's my hypotenuse? How about cosine? Cosine is what over what? Adjacent over hypotenuse. So it will be 11 over the 15. What about TOA? 10. Opposite over 10 over 11. My question to you is, what's good about these two and not so good about this guy? Mathematically speaking, I cannot tell you if you did sine or cosine that you made a mistake. But I can still say that your answer is not the best. Can anyone guess why? The question is, what's so good about 10 and 11 and 15 is not so good? Muhammad, everyone listen up. Say again. Is that exact? Never. The square root of 21 is an infinite number, which means what? At some point you had to what? You had to cut. Cutting means what? You stop short. Which means what? Mathematically, can I use the 15? No, mathematically. Numerically, would I be the best solution? No. Anyone who uses 15 is not going to be as good as someone who uses what? 10 and 11. Because 10 and 11 are what? Are what? What's the opposite of approximate? Accurate. Exact. My job is the 11 and 10. Your job is the 15. Do you see what I mean? So never use anything. By the way, listen up. Do you have sometimes to use rounded values? Yes, sometimes you're stuck. The only number that makes it. How many people have done the sine and cosine law before? We do them a lot in grade 12. Guess what? When you do the sine law two times, you have to use a rounded value. You do not have a way around it. Here we don't. Okay, so what are we going to use? Sine, cosine, or tangent? Tangent, because tangent does not need what? That tangent does not touch, which means what? You could have done the trig part before doing the what? Before doing the what? The length part. Nice. So we're going to use tan. Tan is equal to what over what? Opposite over adjacent. So there you go. What's the short way of saying this, obviously? Okay. Do I know this one? Do I know this one? So can I find the theta or the tan of theta now? Remember, whenever you find an angle, you don't find the angle first. You find the what? You find the trig ratio. So okay, how can I solve this? Who knows how to solve reverse tan or reverse sine? Like usually you're given the angle and you want to find one of the edges. What if you're given the edges and you need to find the angle? Thank you. What buttons usually get used? Second. What else? Huh. Shift. Thank you. Usually there's no more buttons. It's either second or shift. Okay. What everyone? How many people are taking the grade 11 functions now? Have you started covering? Listen, have you guys started covering inverse function yet? Yes. Sine inverse or sine to the -1, cosine to the -1, tan to the -1 is instead of going forward, you go what? I give you a decimal or a ratio. You give me the what? You give me the angle that makes this ratio possible. Nice. So obviously, can I make this a decimal? I can. What's 10 over 11? It's an infinite 0.90, sorry, 0.9090909090. Can you still enter it as a fraction? Yes, you can, but you have to use a what? I'll show you the wrong way of doing it, and you are not going to get the right answer if you don't use a bracket. Either way, you can use a, you can make this decimal as long as you want to maintain accuracy. How am I going to solve that? Is that my angle or the tan of my angle? That's the tangent of my angle. How do I do it? You said it. What do you hit? You shift or second or reverse or whatever you need to do. So I need an angle. Question for you, everyone. Can this ever be 45 degrees? What is the only way that that in a right triangle could be 45? If the, which means if the two sides are the what? Are equal. Are those two equal? Do you think this is bigger than 45 or less than 45? Why? Exactly. If it was perfect, it would be 45. But if this guy gets longer, what happens? What happened to my hand? It opened more. So it has to be more than 40. Perfect. But I'm talking about this one. So this one has to be what? Bigger or smaller than 45? If this one is bigger and this one is solid 90, this has to be smaller. Ladies and gentlemen, it is smaller. It is within 2 sig figs. Oh, my bad. It is 42 degrees. Ta-da. Done. That's correct. Oh, hold on. Oh, no need. No need. 48 is this. 48 is this guy. Sorry. Sorry. I was talking about this one. Yeah, 42. Okay. By the way, everyone, just so you know, please please always write it this way. I don't want you to lose marks in math courses because you know what? You did not write the full statement, or you forgot the -1, the inverse indicator, or maybe you put the -1 here. Please always get used to writing it this way. Yes, Ali. And then yes. Uh-huh.
Wait, yeah. Was it angular or whatever?
Oh, okay. Hold on a second here. I know you've covered math so many times that almost every single time you're asked for a degree, it always says what? Round to a what? A whole degree, right? But no, it just happens here that we need to round not to the whole degree, to 2 decimals. Sorry, to 2. Yes, but for some reason, yes, math courses, they always ask you to what? Degrees are always rounded to a whole. Oh, okay, everyone. What bad things could be in your calculator before you begin with that could screw up your math, even though you typed it correctly? And not in degree mode. By the way, anyone here who covered calculus knows that, or even grade 12 functions, okay, knows that there's another measure of angle. It's called what? Anyone? Radians. Please make sure you never see capital R on here. Make sure it's what? Capital D. What you did was, oh, you did sine inverse. We want a tan inverse. Remember, we're not using the, okay, everyone, hold on. So, question. What if I wanted to use, everyone, eyes on me. What if I wanted to use sine? Instead of opposite over adjacent, it has to be what? Opposite over what? Which means gotta be 10 over what? Or maybe I should better use what? You know, never use that. Go back one step to have more. So everyone, I'm gonna do it using Omar's calculator. I'm gonna divide 10 divided by what? 14.9. And then I'm gonna sine inverse that. Shift sine of the answer. 42 degrees. So it doesn't matter what you use, but your answer with sine or cosine is not as what? Is not as good or close or accurate. Perfect. Okay. What's up? Uh-huh. Everyone, shh, listen up. Yes. Oh, okay. You use any two sides that are either both available or are the best to use. In this case, even though, okay, everyone, listen up. Sally's saying in math, use the two sides around the angle, right? Like this guy and this guy. I'm not saying you can't, but I'm saying what's the problem here with this side? Numerically, it's what? It's approximated. If you want to find the what, sorry? Oh, yeah, of course. Well, you still can use tan, but this time it's going to be opposite here and adjacent here. Make sense? Perfect. Everyone, question. Everyone, what if someone used this triangle? Hold on. What if someone used this triangle? Are they still going to use the same hypotenuse? Of course, a diagonal to a rectangle separates it into two. But then, instead of opposite and adjacent here, it's going to be what? They're going to give me this angle right here, right? Which is going to be opposite over what? Adjacent. Okay, no, we're not done yet. We just have one more thing to do. Write the final statement for displacement. Ladies and gentlemen, I have a question for you. Where did I start? Here. Where did I end? Did I physically move this way? You can never move on the diagonal. Sorry, on the tilt. Which way did I move first? And then, but in geographical direction? South. And then what? And this is how we write our final statement. Yes. There we go. Delta, go ahead. This is your line. This, everyone, remember asking me, how do you write vector statements? This is how we write them. Vector symbol, delta D for displacement equals 15 kilometers. What do we open? What kind of brackets? The square brackets. Now, how do you indicate which direction goes first? Whichever direction you traveled first. Which direction did you travel first? South. And then you went what? And what do you put in between? Okay, question to you. What, Sally? What if Sally used this triangle? Which direction would she move first? But what about her angle? It's not gonna be 42 degrees. It's gonna be what? Does anyone know what's the name of the angle? Two angles that add up to 90? Come on. When you get 42, what do you call the angle that takes it up to a 90? But no, that's the one that takes it up to 180. So what? It's not supplementary. It does sound the same. Complementary. Complementary is whatever brings what? An angle to 90. Supplementary is whatever brings an angle to what? No. 180 half circle. Done. That's today's lesson.